And before we get into equations with x and y, let's just have a look at the ones we're used to seeing. Talking about what does it mean to solve 3x equals 12. You guys know from previous units that that means find all values of x that make the equation true. And if we're going to solve that, we're going to divide both sides by 3 here. 3 divided by 3 equals 1, so we get 1 times x is just x. 12 divided by 3 is 4. Going to check our solution now. Going to write it exactly the same as the original, but we're going to put 4 in brackets instead of 12. And the left side simplifies to 12, so we get 12 equals 12. Okay, question 4. Notice this one only has y in it, so same as what we're seeing. We're used to seeing, I should say. Going to add 5 to both sides here. 23 plus 5 is 28. We got 2y, and then negative 5 plus 5 is 0. Divide both sides by 2. 28 divided by 2 is 14. 2 divided by 2 is 1. So we get 14 equals y. And for some reason I've drawn this line here and wasted the rest of the page, so I'm going to do my check below that line. Remember our check, we write it exactly the same as the original, except for instead of y, I'm going to put 14. Okay, bed mass, 2 times 14 is 28, so I get 23 equals 28 minus 5. And 28 minus 5 simplifies to 23. So that's true. So when y equals 14, that makes the equation true, so it means it's a solution. Okay, let's have a look at an equation with x and y in it. And not surprisingly, if we want to solve this, we still need to make the equation true. In this case, we need to find all values of x and y that make the equation true. Okay, and 7, we want to find a solution to this. Notice there's no point in rearranging this or anything. We just want to find an x and y that's going to make this equation true. So let's see here. If x equals 1, say, then that side would simplify to 4. That would mean that y would have to equal 4 to make that true. Let's do a quick check. Y is 4. X is 1. So we need to put those in brackets to show that those used to be y and x. Left side's 4. We can drop the brackets because we already know that it used to be a y. And 1 plus 3 simplifies to 4. Good. So when x equals 1 and y equals 4, our equation's true, so that is a solution. The lazier way of writing this, x equals 1, y equals 4, you've probably seen before, is we write bracket 1 comma 4. You need to be really careful when you're writing it this way, that the x is first and the y is second. But if we just write that without the x and y above it, we just write brackets 1 comma 4, that tells us that x equals 1, y equals 4. Okay, 8. Is that the only solution? Well, let's see. If x equals 0, y could be 3. So yeah, obviously not. No. Okay, so let's put some of those solutions in this table. We already know that when x equals 1 and y equals 4, it's going to be true. And the other one we just figured out was x equals 0, y equals 3. Let's do one with a negative. Maybe x equals negative 1. Y would have to equal 2 to make the equation true. Maybe x equals negative 5. Then y would have to equal negative 2 to make the equation true. Let's do one with a decimal. Maybe x is 1.5. That would mean that y would have to be 4.5 to make it true. And if x was negative 1.5, then y would have to be 1.5 to make it true. Notice there's nothing special about these x-y combinations I'm finding to make the equation true. They're just the ones I decided to write down. Okay, and let's do some big numbers now. Let's do like, if x was 1,000, then y would have to be 1,003. And what if x was negative 1,000? Then y would have to be negative 997 to make that true. Okay, is it possible to write down all the solutions to this equation? No, I'm sure you guys can see there's always going to be more solutions, right? You know, we could use x is 10, we could use x is 1,000, and then we'd be able to find a y for that. We could use x is negative 3.224454, and we could find a y that would make that true. So is it possible? No. So notice, we can't write down all the solutions. If we tried to, it'd take our entire life. We'd die broke and alone and depressed, and our lives would be horrible, all from just trying to write down all the solutions to this equation. So obviously there must be a better way than wasting our entire lives trying to write down the solutions to one equation you got in math class. And that better way is we can show the solution on a graph. So for those of you that don't like showing solutions on graphs, well, it's a hell of a lot better than wasting your entire life writing down solutions to one equation. So if you think about it that way, it's not so bad. Okay, so let's have a look at our first one. We've got 1, 4 is right there. 0, 3 is right there. Negative 1, 2 is there. Negative 5, negative 2 is there. 1.5, 4.5 is there. About. Negative 1.5, 1.5 is about there. Oh, and now we've got like 1,000, 1,003. Well, that's going to be somewhere way off the end here, like way, way off. And same with the negative one. Okay, so let's think about where the other solutions are going to go. Well, pretty obvious to see that these are in a straight line. So let's just try. It looks like this one's going to be a solution because that's in a straight line. So that's the 2, 5. So if I put in x equals 2, y equals 5, yeah, that's true. I'd end up with 5 equals 5. This other one in the straight line, we'd get 3, 6. Yeah, if x equals 3, y equals 6, that's true. Okay, good. So all of these points along here are going to make the equation true. Okay, what about between those points? Well, what if we did 0.1, 3.1 right there? Yep, 0.1, 3.1, that'd make it true. And in fact, I'm going to have an infinite number of decimals in between here and here. So I don't want to draw in an infinite number of points. So what I want to do is draw on a line, and that tells us that there's an infinite number of points between there. Notice, in this unit, sometimes there'll be an infinite number of points in between these dots, and sometimes there won't. For example, if we're talking about the number of DVDs, you can't have 1.3 DVDs. It's impossible. It wouldn't play. It's garbage. You can either have 1 DVD or 2 DVDs, but you can't have 1.3. You could have 1 DVD and some garbage, which is still just really 1 DVD. Okay, so we know that all of these infinite points in between are also going to make our equation true. So we're going to draw that line in to show all of these. Like for example, here we've got, what's that going to be? 2.1, 5.1, 2.2, 5.2, 2.137995545, 5 point whatever I just said. I can't even remember. Okay, so we've got all those infinite points in there. Okay, now let's talk about the 1,000, 1,003. That's going to be way off the end here. In fact, there's going to be an infinite number of solutions way off the end there. So there's nothing special about 1,000 and 1,003. Sometimes people like to put a dot here if it's in their table of values and write 1,000, 1,003. There's no reason for that. There's an infinite number of solutions that don't fit on this box, on this square, and 1,000, 1,003 is just one of them. So we're going to draw an arrow here to show that there's an infinite number of solutions along that same line that way, and draw an arrow there to show that there's an infinite number of solutions along the line that way. Okay, so let's have a look at another one of these. So here we want to do a table of values and graph the solution to y equals x minus 3. As we just talked about, there's going to be an infinite number of solutions. The question is, obviously we don't want to do more than we have to. So what's the minimum number of solutions we need to find to figure out where a straight line is? Okay, let's find one solution. 0 for x is always a really easy one to start with. So if x equals 0, 0 minus 3 would be negative 3. So if x equals 0 and y equals negative 3, that would be a solution. So let's put that on the graph, 0, negative 3. Right there. Okay, well that doesn't tell me where my line is. The line might be going through that point like this. It might be going through that point like this. We have no idea. So 1 point is definitely not enough. Okay, let's find another xy combination that makes this true. Just for the heck of it, I'm going to go x equals 5. 5 minus 3 is 2. So if x equals 5 and y equals 2, that'll be true. So x equals 5, y equals 2. Okay, and now there's only one way a straight line can go through there. Okay, the problem is you guys aren't perfect. So what I like you to do is I like you to find 3 points. Because if you find 3 points and they're not in a straight line, you know you made a mistake. If you've got 2 points, you don't know if you made a mistake or not. The other thing I want you to do is I want you to make sure that your x's don't form a pattern. Remember, we're just trying to make this equation true. If you guys form a pattern with your x's and y's, it's always going to be a straight line, whether it's correct or not. So 0, 5, 10 would be the pattern, so I need to make sure x isn't 10. So let's use x equals, I don't know, negative 2. That's definitely not a pattern, 0, 5, negative 2. Okay, if x equals negative 2, I've got negative 2 minus 3 is negative 5. So let's go negative 2, negative 5. Ah, and good news. Those are all in a straight line. If those 3 points formed a triangle, you did something wrong, go back and check. Maybe you did your chart wrong, maybe you put them on the graph wrong, but you did something wrong if they're a triangle. The good news here is we didn't make a mistake. So they're in a straight line, so I'm going to draw in all the other, or where all the other infinite solutions would be, using my ruler here. So all of the points on that straight line would make this equation true, including the ones that keep going on forever. Also, please make sure you draw your line all the way across the square and then put the arrows on the end. We want to show as much of the solution as we can on the graph. Don't give me like 3 points in here and make your line like from there to there, right? Draw it all the way across. Okay, let's have a look at 14. So, same as last time, we just need 3 points to make sure we didn't make a mistake. I like to use x equals 0 because it's easy. 2 times 0 would be 0, so if x equals 0, y would be 0. Okay, let's get another one. Again, I'm just grabbing points here. Let's go x equals 3. If x equals 3, the right side would be 2 times 3, which means y would have to equal 6 to make that true. And now we don't want x to equal 6. We don't want a pattern. So let's go negative 2 again. 2 times negative 2, the right side would be negative 4, so we need the left side to also equal negative 4 for the equation to be true. Okay, and now let's put those on our graph and see whether or not we get a straight line or a triangle. If it's a triangle, we need to go back and see what we did wrong. 0, 0, 3, 6, and negative 2, negative 4. Hey, straight line, good news. Okay, so I'm going to grab my ruler and show where the rest of the solutions to that equation would be. There we go. So every point on that straight line is going to make y equals 2x true. Every xy combination on that line. Okay, just got a couple more. 15, negative y equals negative x plus 1. Highly recommend you guys rewrite this. You guys remember that negative x is the lazy way of writing negative 1 times x. So let's rewrite that as y equals negative 1 times x plus 1. And that's going to keep us from making mistakes. A lot of people get messed up with a negative x. Okay, I'm going to start with 0 again because 0 is easy. Negative 1 times 0 is 0, plus 1 is 1. So the right side is going to simplify to 1 if x equals 0, which means y should equal 1 if the left side is going to equal the right side. Okay, next one, let's go x equals 2 for the heck of it. So if x equals 2 here, I have to go 2 times negative 1 is negative 2, plus 1 is going to be negative 1. So if x equals 2, y will have to equal negative 1 to make the left side equal the right side to make the equation true. Okay, and now we don't want to use x equals 4 here. Now let's do x equals 5 instead. Definitely not a pattern. Okay. 5 times -1, -5, plus 1, -4. So y would have to equal -4 to make the left side equal the right side. Okay, let's put our points in. 0, 1, 2, -1, and 5, -4. Oh, good news, straight line again. I'm just going to move the page a little bit here so I can draw my straight line. So every point on this straight line, every xy combination on this straight line is going to make the equation y equals -x plus 1 true, which is of course the same as y equals -1 times x plus 1. Okay, so again, highly recommend you guys rewrite it like this. I see tons of mistakes when you guys forget to rewrite it, and you guys usually get it right when you do rewrite it. Okay, last example. 16, we want to show the solution to y equals 2x minus 5 on the graph. Again, x equals 0 makes things easy. 2 times 0 is 0, minus 5 is -5. So if the right side equals -5, the left side would have to equal -5, so y has to equal -5. Okay, let's go x equals 1. 2 times 1, 2, minus 5, -3. And now we don't want a pattern, so let's go 5. 2 times 5 is 10. 10 minus 5 is 5, so 5, 5 is an xy combination that makes that equation true. Okay, here we go. 0, -5, 1, -3, and 5, 5. Ooh, is that a straight line? Sometimes you need to get your ruler out and see if it's a straight line. Yep. Yep, those are in a straight line. Okay. Drawing our line to represent all of the xy combinations that make y equals 2x minus 5 true. Okay, you can get to work on your assignment now. Enjoy.